Hello, I'm Mark Fletcher from Chicago Pneumatic Tool Company. Today we're going to talk about the basics of Air 101. What does that mean? What it means is how do you get the best performance out of your tool, the best durability, and how to make the tool work correctly. First off, when you purchase a Chicago Pneumatic Air tool, you get what we call the operator's manual. In the operator's manual, it gives you a quick description of what you need to run the tool. There's a little diagram at the very top. It shows the tool, and then it's got a whip hose on here, which is 3/8. And what we mean by 3/8 in this application, actually in all air tools, is 3/8 inside diameter. And we're going to get into a little bit of that a little further down the road when we get into the couplers and plugs. The next is your main line hooking to your hard line, and it's 3/8 as well. Also, you have your FLR, which is your filter, lubricator, and regulator to adjust your air to the tool. All air tools run at 90 psi. I should say 95% of them run at 90 psi. There's a few tools that we don't have to do that on, like screw guns, screwdrivers, and air engravers. You can adjust the air lower for them and they'll operate fine without harming the tool. We're going to start off with what the difference is in nipples and plugs. These are the units that screw into the bottom of your air tool, like this particular one is on my test gauge. And I ran a test gauge into this tool so I can show you what the air pressure is, because our air pressure is the life to the tool. First of all, as it says in our instructions, is we use a 3/8 plug. Well, what that means is that the hole in it is 3/8 inside diameter. These are the nipples that are quarter NPT. And what that means is NPT stands for National Pipe Thread. And all three of these are quarter NPT. The difference is, and it's hard to see them through this angle, but we'll flip them over and you can really see them this way. There, it's easier, I'll just get that one out of there. There you can see the actual difference. Okay, this is a 3/8 by quarter NPT. This is what you should be using on any 3/8 line, because this plug hole in here is 3/8 inside diameter to match your air hose. This particular one over here, it's a quarter by quarter NPT by a quarter port. What that means is that it's smaller, so the flow is restricted. This is what's going to slow your tools down. Again, as we mentioned, it's got to match your air hose size. So that's a quick little idea of how it goes. 3/8 NPT is the same principle. It should be 1/2 inch holes. And your 1/2 inch should be the same as well. Okay? That's what we have for, and it doesn't matter whose you use, it's the size. So now what we're going to do is we're going to show you with the small hose and the small coupler, not the regular coupler that you should be using, what the difference is. And we're going to plug this in. We're going to turn on our air, okay? And we're going to move this like so. And right now it's saying we have 90 psi. Now, I can tell already we're restricting the flow to this tool because of the small air nipple. That's this little fella right here, okay? And how I know that is because our compressor is set at 112, and we're only pulling probably about 90, maybe 100 pounds through here, okay? As I mentioned earlier, air tools run at 90 psi as they're operating. So what that means is, as you're pulling the trigger, doing a job, or under load, you should have 90 psi. So let's test it. As you can see, it dropped down to 60 pounds. What that means in performance is that this tool is rated at 960 foot-pounds with this nipple, this one right here, okay, and the proper hose size. By using the small nipple with the same air pressure, we drop down to 60 pounds, which means we're pulling about 500 to 600 foot-pounds of torque instead of 960 with this nipple. In translation, you're making your tool work harder. It's also making your compressor work harder because it's chasing more air. It has to deliver more air during that time period. And your performance in getting your job done is taking you long. So your production is down as well. But it's also hard on your tool because you're making your tool work harder. You're thinking, well, I haven't got enough air pressure going through it to bother it. But actually, it's the work you're doing because you're making it work longer. Okay, and you're stressing it by trying to push it to its maximum torque that it cannot achieve. It's the same principle if you take the fuel line in your car for your mechanics and you pinch it by half. Are you able to drive the car? Yes. Are you able to go to 120 miles an hour? No. Are you able to pull up to driving speed? Yes. Can you do it very fast? No. Your acceleration's low. But the other problem is you're burning a lot of fuel. Air tools are no different. If you have a restriction to the tool, you won't get the performance of full power out of it. It takes you longer to pull that up, and it's harder on the tool. Okay, so we've seen that. And we're going to step up now to the proper size air nipple that we just talked about. And as I mentioned earlier, we've hooked up a gauge to this so that we can see what it's doing. Or you can use the air regulator gauge on your regulator. Okay? Now, we have a proper size here. And we're hooked up. And we got proper air pressure. Now I'm pulling about 110 psi, as before we weren't even pulling 90. So that's how much difference it's made. Okay, and now when I pull the trigger, you can see that we're running 90 psi through the tool as it's operating. That's what we want. Now this tool can pull 960 foot-pounds in probably about a 5 to 7 second run. You're going to get your job done quicker, your tool is going to perform better, and it's less wear and tear on your tool. Your compressor doesn't have to push as much air to keep up. So all in all, this is the way to go, 90 psi. Now we're going to step up to the 1 inch and we'll show you the difference. We're going to use the same air pressure but bigger lines. And what we're doing is showing you CFM to pressure so that you understand or know that if you have my 1/2 inch is working really good in my small tools and you plug in your 1 inch and it's going down, it's because you don't have enough CFM. There's a chart related in this video that shows you the CFM, and that's something to follow by. Right now we're going to try a 1 inch impact so that we can show you the differences in the hose size. The hose size, you would think, gives us more performance, and in principle it does, but it's the same theory. If the restriction is there in this coupler and hose, it's going to restrict the flow of air to the tool. So right now we have approximately 110 psi at the tool. That's, as I've mentioned earlier, that's static pressure. So when I pull the trigger, we should be 90 psi. We're not. We're running 80 psi. So what's happening is that we're losing CFM, which is there's a restriction in this hose. So I'm going to stop, I'm going to bleed down this hose, and I'm going to hook up another hose that I know is the correct size and correct fitting on it, and we'll be able to run the test again. Okay? Now, I've changed hoses and put a different coupler on it. Okay, and we'll see what the difference is. Now this is a true 1/2 inch with a 1/2 inch inside diameter hose and coupler. So our pressure is still the same. We're at about 115 pounds, but let's see what it runs at. And we're running at 90 psi is right where it should be. So as we can see, this is what happens if we have a restriction in our line, and this is what to look for. If you know you got the proper air pressure coming from your compressor, but the tool's not performing, check your air out. As we've just demonstrated with the 1/2 inch impact, with the smaller air nipples, and with the 1 inch, you can see what restriction does. And this is what causes poor performance in your tools. All it is CFM and PSI. And a restriction is cutting the flow of air to the tool so that the tool is not performing correctly. As I mentioned earlier before, what this does is it cuts down on your production. It takes longer to do the job. It's harder on the tool because it has to work harder. Your compressor's got to supply more air to the tool because you're taking longer to do the job, okay? Because you're running under 90 PSI. 5 pounds either way isn't going to make a lot of difference. But if you're running 80 PSI or 75 or 65 or 60, it's going to affect your performance and your production when you're doing your job, and it's also going to compensate the durability on the tool. And what that means is you're making the tool work harder because it's not pulling up. In this particular application, this tool is rated at 1900 foot-pounds in reverse with the proper air, as we just showed. But with the one before, it'd probably be pulling 1600 foot-pounds. So it's going to take longer to do the job. So this is one of the things that you've got to watch for. This is a FLR unit, and you should be using one of these in the shop. They're very handy and they are necessary. We're going to quickly go through them today so that you can have a better idea of what their principle is and how they work. FLR stands for filter, which is this area here that separates moisture from the line and keeps it from not going into the tool. And then you have a regulator that you can adjust, and then you have your lubricator. Turn it on and you can see that it brought it up to the proper pressure. Okay, and then you can adjust your air pressure to whatever you need it to be. Now, why do we do this? FLR regulators are designed so that if you're using equipment in your shop like a tire breaker or a spreader, or let's say a 4 horsepower grinder or a cement vat, or a mixing vat that runs on pneumatic air. Those type of units use 140 to 160 PSI of air pressure and a lot of CFM to make them work. Well, you don't want 160, 140 PSI running through your tools. So wherever your tools hook up, you would put this as a separate unit so that the air is controllable to your tool with a separator, with a regulator, and with the lubricator. Now, I don't know if we can see it, but we'll give it a quick little try. If we can see the little dots here, you might be able to see them. There goes one. What's this supposed to do when they're set up correctly, depending on your tool? You can adjust this flow of 1 drop per minute or up to 3 drops per minute. Actually, you can go all the way up to 5. Or you can change it so that it's 1 drop every 3 minutes. But that's the whole idea. It has a regulator valve in it, so you can tell that there's oil in the unit, and it supplies oil into the tool. So that's what an FLR does. What we're going to talk about now is how to oil your air tool. All air tools say that they should be oiled daily. What does that mean? What it means is you're lubricating the air motor in the tool. It's an air motor just like an engine. It needs lubrication. If you oil it in the morning, we say thank you, because that way you're conscious of oiling your tool and taking care of it. But if you oil it in the morning, all you're doing is blowing the oil out of the exhaust and away from the tool, and the tool will be dry. The best time to oil your tool is at night. Now, before we get to that, why is that? Chicago pneumatic tools are tested and assembled with oil already in the air motor. So when you get it, it's oiled and ready to go. Okay? The other thing is it's been soaking for a long time with oil, in the vanes, seals, and bearings. So it's well lubricated. So after you've used it a few times during the day, that lubrication is gone. At the end of the day, when you're finished your shift, and if you're not using an FLR system, is to use an air tool oil. And buy yourself a good air tool oil. Okay? Now, what you do is you unhook your tool, take your bottle of oil, open it up. You don't need very much, so I don't spill any here. You just give it a couple of drops, 3 or 4, doesn't need very much. Hook your hose back up, okay, and you burp it. That's all you do. What that does by running the air motor with the oil in it, it atomizes the oil into the vanes, seals, and bearings and blades of the air motor. And then you unhook your tool, put it away for the night, and away you go. Now, especially over a weekend, it sits and soaks with oil into the seals and vanes and bearings. And that way it's ready to go whenever your next shift is to run that tool. And it's got proper oil in it, and it works very, very well, and you get a lot longer life out of your tool. That's the best way to oil your tool. Thank you.